My name is Tom Grise. I'm Director of Services for North America at Cedexis. Thanks for having us up. This is actually my first meetup here in Boston, so it's pretty cool to kind of see the scene up here. What we're going to talk about today is multi-homing of your delivery strategy, whether that is via CDNs, data centers, clouds, what have you, so, multiple servers. That sort of conceptually is probably a bit of a prerequisite to the talk, but understanding why you want to have redundancy when it comes to your internet workflows, pretty universally understood at this stage. Something bad happens, somebody kicks the power cord out of one server, you want to be able to fail over to the other server. So what Cedexis kind of does with that in mind, and the desire of people to kind of take this idea of providing different options and different redundancies for delivering your content, we essentially end up scoring the sort of the public CDNs, content delivery networks, clouds, some of the popular data centers that are out there, via this massive community of RUM data. And I'll get into exactly what that is, but at the end of the day, we're providing a picture of what the actual performance is from the perspective of end users, which is unique, relatively speaking unique. We're the first company to really do that on a very broad scale. So what you're looking at here is, we call it Radar Live. It's essentially bubbling up a lot of last mile measurement data like I've been describing, and putting it in this nice, flashy, kind of very marketing-friendly UI. You can go to live.cedexis.com at any time and sort of check on the map of the internet and see where there might be some of these anomalies that you're seeing showing up right here. And what each of these little sort of beacons are calling out these anomalies. And anomalies, as we describe them, are really just sort of any deviation from the observed norm. So if it's a spike in latency, if it's a drop in reachability, also kind of known as availability. I like the term reachability because the server might be on, maybe it's available, but can you reach it? That's the actual idea. That's what really matters to your end users. Or a drop in throughput, something like that. So this will absolutely light up like Christmas if there's like a cable cut. It's a fun place to go. So maybe put a link to it in your shortcuts, so you can kind of go to it if you ever see anything really terrible happening with the internet. We can kind of show you a little bit of detail about what happened. So just a quick dig through this. If I click on any one of these in these countries, like here's what looks like a problem in the UK. Over here, I'm calling out that this is a problem with anonymous SSL, which is the name of a CDN. It is anonymous because it's representative of the actual delivery footprint of Akamai. But we're sort of from a legal perspective, we're only able to really show call the Akamai platform the really good one that they allow people to sort of do their trials on, which is it's fair, but we like to just make this data available. So what this is showing is that there was an availability, or actually no, excuse me, that was a latency increase, as you can see. Up to 55 milliseconds, down from 19 milliseconds. I mean, Akamai has incredible latency, typically. On a global scale, they're usually sort of in the front. A couple of challengers coming up, though, and we see in certain regions, we'll see certain CDNs beating Akamai. What happened over 5 minutes? We saw this spike in latency, and it affected the United Kingdom and the United States. So some set of servers potentially had an issue serving into those countries. So that is Radar Live, and what I want to do is kind of get into this here. Founded in 2010, the goal was essentially just to make things faster. So web performance in general really is a lot of different workflows in the vein of web performance can be addressed with the set of tools that we provide. It's kind of it's fun to watch our customer base and the actual workflows that people come to us with. They drive our product pipeline, because some of them are just great ideas we didn't think about. But as we talk about the sort of the core tool set, might start to paint a picture of why it's very extensible. Started by a couple of guys from Akamai. One, Marty Kagan was VP of engineering, I think, held a couple of the really early core patents on some of the Akamai technology. And a guy, Julian Colomb, was running sales in Europe, I think, at the time. But they basically parted ways with Akamai and had this idea for Cedexis. So we've got a bunch of different offices around the globe. Josh and I sit down in New York. And across the bottom you see some of our customers. The idea of web performance and why this is important is probably not news to some of you folks, especially the guys on SAM. You understand what site performance means to bottom line probably better than I do. But just to call out a couple, I think at bottom right, 1% loss in sales that Amazon attributed to a 100 millisecond slowdown, which for them is just like millions of dollars. So bottom line, it's important depending on what type of workflow or business you actually work in. It does matter to you. The core value proposition that we provide is this visibility into end user experience and that network performance from the end user's perspective. Prior to our radar platform and our intelligence platform kind of growing to the level that it has, a lot of people relied on things like Gomez or Keynote, a lot of what you might call backbone benchmarking, doing testing from actual servers that are typically sitting in data centers, which if you think about it, I mean, what you actually care about is your end user's performance. So they're not going to have the same network conditions that a data center has, especially when you're talking about connections to edge nodes that are probably in a data center. So it's data center to data center type benchmarking, which really doesn't matter that much in the grand scheme of things. So our idea was to create that intelligence from the end user's perspective and see what we could do with it. So the way we ended up doing it was we have what we call our radar beacon, and radar is this giant telemetry platform. It's kind of, I describe it to my mom that it's sort of like the Waze of the internet, the Waze traffic app, if you will, in the sense that via this radar beacon that people deploy to their websites, and it's on Tumblr.com, LinkedIn.com, some very big ones, and then about 850 smaller ones, but. At the end of the day, it's a ton of measurements. It's up in the realm of 6 to 8 billion on a typical weekday of actual last mile transactions that we're able to quantify for latency, throughput, reachability, etc. Kind of the core metrics that you might really care about, throughput. So what you do with that data is, you get the intelligence, but you can actually wrap that into and process that into actionable data. So that's sort of, after we actually have the intelligence, making it actionable is really kind of the next step, and that's actually our core business. The radar benchmarking solution is free, and it's crowdsourced. That's how we grew it to be 6 to 8 billion a day. It's about actually just taking sort of I mean, we started in France, so it's a little socialistic in that way. But it's really everybody sort of contributing to this global data set. It's all anonymized, passes all sorts of privacy concern tests and everything like that. But to really kind of create this global picture. So as I was saying, we got the measurement piece, the load balancing, and then the impact, which I'll spend probably a little bit of time on a bit later, are the actual revenue pieces of our business. The load balancing is taking that actionable data that the radar community provides and actually condensing that into something that allows you to direct your end users to the best path. Back to that Waze example, explaining to my mom that if if a bunch of people encounter traffic or construction, that intelligence will essentially affect the people that come after them. And maybe you'll go another route. Maybe you'll get off that exit before you hit that traffic. Really very much the same, and the analogy is actually really good for what we do with that sort of internet congestion, internet traffic data. Just a quick demo from a workflow standpoint of how Radar actually works. So let's say that somebody is in Toronto, Ontario on the Bell ISP. They visit businessweek.com. It's actually bloomberg.com/businessweek now, since they've sort of consolidated those things. But bottom line is that they will wake up a tag. This tag is typically about 8 lines of JavaScript, and it sits in the footer of your HTML. It's really easy to deploy, typically works, just kind of plug and play. What it's engineered to do is actually wake up after the onload event. So if you care about web page performance, you clearly don't want any of this to be happening in front of the stuff that your users actually care about. So after all the content's on the page, you have all the items for Wayfair or whatever their cart, whatever their search is, on the page. The DOM onload event fires, and then our tag wakes up. It's configurable. The default is 2 seconds, just to be a little conservative, because we really don't want to affect end user performance. But it'll wake up and essentially start taking measurements. And here, what we're illustrating is just 4 different, we'll call them CDNs for now. And it takes these 3, and it notices that CDN number 2 is down, right? It just doesn't respond at all. So what we'll do is that essentially that will get reported into the Radar database. And then short time later, somebody wants to go to tumblr.com. So a different website, but tumblr.com, this user coming from the same ISP in Toronto, and that's important, and I'll get to that in a moment. Turns out Tumblr uses Cloud 1 and Cloud 2, or CDN and CDN 2. We know from this end user seeing that CDN 2 was unavailable, so what we're going to do is actually have that open mix, that's our load balancing piece, basically say, well, look, CDN 2 or Cloud 2 is unavailable, so go to CDN 1. So that's a user who gets their content. The page loads up, the file is downloaded, whatever it is. They're saved from having to reload or have somebody in a knock in the middle of the night wake up and change some of your settings on your load balancer. This all sort of happens, this is one example, of course, talking about the actual decisions, and the data that we get is in billions of times per day. So in aggregate, being able to actually affect that sort of logic in real time automatically saves your users in aggregate quite a bit of time. And I've got a slide on that in a little bit that talks about like what it actually looks like when you roll up all those micro outages, like we call them. It's significant. I mean, it's significant user time that you're saving, essentially. So this is kind of the whole Cedexis ecosystem is built around the idea of the multi-homed delivery strategy. So we spend some time talking up multi-home strategies like we are today. But it's, people are kind of coming around on it, and I think that, for the most part, most large-scale architectures that are sort of beginning now are kind of being built with that in mind, at least hopefully, so that you can leverage multiple CDNs or multiple clouds, and that you're essentially treating those different platforms as commodities. They have, certain strengths and weaknesses. There are some functionalities that certain CDNs have that others don't. But certainly at sort of like the core services like static file delivery, right, like caching at the edge for files, all CDNs can do that. So that's a great use case, and that's probably one of the earlier use cases that we had. Or like dynamic content acceleration, without some of the bells and whistles that you might require at a basic level. Most of the CDNs can do that. Not as many as can do basic caching, but this is kind of the Cedexis ecosystem is really a set of tools to help you orchestrate that. So we've we've attempted to basically put an abstraction layer on top of CDNs, on top of clouds, on top of data centers to sort of affect them effectively manage them the same way you would with a hardware load balancer, only with a lot more flexibility, a lot more ease of control. It's kind of endlessly flexible the way you actually build your routing logic, and we can talk about that in a little bit. Oh, quick note actually. So the radar telemetry that we actually feed into the open mix load balancing for those decisions like we saw, that's one piece of the puzzle. It's great. Some of our largest customers will basically just do latency-based load balancing to get the web service from the closest data center, or latency-based web load balancing to the best CDN for that particular user that's coming in to get cached object or non-cached object, what have you. But the flexibility comes from our ability to pull in these third-party data feeds. We pull in data from CDNs, so usage data, capacity, bandwidth. If you're somebody that watches the actual bill on those providers, we can help you really efficiently manage your actual contract spend. So if you've got like a, you've got a commit that you got to hit every month with a specific CDN, we can kind of nudge the traffic. Like you're load balancing on performance, but you're nudging the traffic so that you're able to actually just get the best bang for your buck at the end of the day, right? Or if you've got like bursting penalties above like a 95.5 model, above like a gigabit per second, you could sort of just hit the usage API feeds for those CDNs, pulling that data into the load balancing app and just make sure you don't burst. So that's one example. Server data, application monitoring, Rigor, New Relic, systems like that, Thousand Eyes. They do certain things very well. We don't play in that space, but they're essentially they're providing intelligence that's different from what radar provides. But it's very useful and very important to end user performance. So you can kind of pull that in and sort of script your routing logic any way you want. Trusted by a bunch of different brands. Radar's huge. Sign up for a portal account at www.cedexis.com. There's a sign up in the top right. It's free. You get in, you can contribute to the community. We give you your own tag with your account. You can deploy it on your site. What that'll give you is that intelligence of your user base, essentially what the performance looks like to these sort of public CDNs, if you will, the ones that kind of the market cares about, Fastly Akamai, AWS, Google Compute, so on and so forth. So if you're evaluating CDNs, this is pretty useful. You can go in there with that tag deployed and say, all right, now I know how these different CDNs or these different cloud clusters. And we break it out, right? There's AWS East, West, the various different regions. You can see where you should maybe focus your spend. Where should be the next point of presence or the next CDN you bring on, right, to sort of fill the gaps that you might have in India or China, or the BRIC countries. To really best fulfill the web performance needs of your customers. I talked a little bit about how radar works. I think it's important to kind of understand, so I'll go a little bit more into detail with it. The tag that I mentioned, the 8 lines of JavaScript that's on Tumblr, that is that basically that's the most popular way of implementing the tag. We also have SDKs for iOS and Android. We got a Python framework. We got a C framework sitting around. The idea is that you can pretty easily deploy this to all your platforms. But at the end of the day, what they're doing is they are waking up after the download event, like I mentioned. They're making a call to our what we call our initiation server in it, and identifying themselves. They're saying, hey, I'm on tumblr.com. I'm sitting in Back Bay, Boston, on whatever ISP this is that we're on right now. And our service will basically say, okay, your tag belongs to Tumblr. We've got this set of configurations for what Tumblr wants you to go measure. Go measure them. And the way they actually go measure them is we sort of prior to the actual radar measurements actually occurring, we set up benchmarking probes on these various CDNs. So there are two objects. One is a 50-byte GIF file. The second one is a 100-kilobyte PNG file. And if you make those sort of HTTP or HTTPS accessible on those properties, what the tag will then do is go pull that down. 50-byte GIF file, it's one round trip. We hit that once for what we call our reachability or availability tests. Like, was I able to actually get this object? Yes or no, that's it. With that existing connection, the next time, the reuse connection, we then pull that same object down again. We do browser cache busting and all that stuff. But the idea, since you have that pre-warm connection, is to really just get that very pure network latency request return. So your round trip, we call it RTT for short. But you can think about it as sort of very basic level latency of the network between user here in Back Bay on ISP. What ISP are we on? Any idea? We'll say Comcast? Say Comcast. So Comcast in the Back Bay, and that'll constitute a measurement. And maybe that object was sitting on Fastly. And essentially that would basically bubble up into repeat that process millions of times a day. That's how we sort of get that very dense data set. It is a numbers game. Network performance is noisy, as you may or may not know. So the actual volume of data that you're collecting is really critical to crunching it down to something that's actually actionable and a trustworthy benchmark. So that's one of the kind of the core differentiators of Radar is this very vast crowdsourced community that we've been able to put together. So we do that for the GIF file for latency. We go out and pull that PNG file, the larger PNG file. We extrapolate the throughput of that transaction, and we bubble that up. We will report that into our portal, but we'll also very quickly make it available to the load balancing applications in seconds, sub 10 seconds, on a global scale. You can get any sort of region that decision. If you were here and you wanted to understand what a decision should be made for a user in Beijing to whatever CDNs you use in Beijing, that's sub 10 seconds of actual live delay on a global scale at all times. So, number we're very proud about, to actually take all that data and crunch it down into a decision, routing decision. We can also do custom measurements. The ones I just described are sort of the default. It's important to have apples to apples to make these comparisons. Really with that benchmark I just described, we're trying to solve this problem, right? Is the idea that there's a really complicated set of pipes out there that we call the internet. And it's really noisy. It's a bit of a nice eye chart, these slides, but what we want to do is sort of make this, depending on, or really think about this in all of its complexity as really one transaction to monitor, because that's all that matters. I mean, if we get to the place down the road where we could actually, probably take different protocols that exist right now, do some routing between the different hops within these transactions, maybe we'll do that. But right now where the market is, and since you've got things like content delivery networks or clouds, that's your endpoint. That's as far as you control. And it's Wild West, really, between that and your end users. And the idea is to just, regardless of how complex that last mile path is between the edge of your network and the end user, we're just benchmarking it. And your CDNs are going to have different response times, different throughputs, different reachability on these different networks. And that's kind of like, really what we're doing here is we're trying to extend your level of control out, as far toward the end users as you possibly can. So, what do we see? I'm going to talk about performance, and then I'll talk about reachability, or outages, microoutages, if you will. So CDN performance is inconsistent across different eyeball networks, and where you win today, you might not win tomorrow, or in an hour. It's very noisy. So this visualization, we call it an S-curve. It's kind of useful to illustrate the benefits of having two delivery endpoints instead of one. Really like the core multi-home, right? Multi-homing your delivery strategy. And what we're doing here is we're on the horizontal axis, we're just outlining your audience, basically. And using, this is based on real data, using the radar tag to basically measure the latency between your users in CDN1 and CDN2 allows us to kind of create this type of a graph that then says, okay, if I'm on this side, the user would be best served by CDN1. If I'm on this side, on the bottom, the user would be best served by CDN2. And this is on, I think this is on 2 CDNs on a global basis, and we'll drill down in a couple of more granular geos. But the idea being that there are, vast quantities of your user base are going to be preferring CDN1, and not as many, but still a significant chunk are going to prefer CDN2. And so you want to direct them that way, because I mean these are really huge differences in latency that you can actually be saving some of these users. I mean down here is kind of the extremes, but not terrible. I mean this would be the 95th percentile potentially for 5% of your user base are going to see about a 30% improvement in latency if you pick CDN1. Whereas over here it's sort of the opposite. Not as extreme like I mentioned, but here, I don't know, somewhere around 4% of users are going to see that they'll see a 10% improvement by going to CDN2. So this is kind of like the basic premise of sort of the idea that you kind of can improve performance by providing two different options. And it's very hard to sort of show more than 2 CDNs on a graph like this. We kind of have to use some other types of visualizations. I do have some, which I'll show you, but they're kind of eyesore. So I like to kind of talk about this very basic one. And this is kind of like, you could kind of go either way in here, right? Like either CDN that you pick, you're not going to get huge performance benefits. So this goes back to what I mentioned earlier about bringing in some other types of data into your decision making. So maybe CDN1 is, actually maybe CDN2 is way less expensive than CDN1. So maybe within this band, which accounts for 35 plus 15, so half your audience basically, right? My math is good. So half your audience, you can basically just do cost savings, right? Because you're not going to be seeing dramatic performance benefits by picking the fastest CDN, maybe 5%. You can just program your app to automatically say, okay, it's about the same, let's just give it to the cheapest CDN option. Depending on the types of contracts you have with your CDNs, we always like to stay sort of out of those discussions. We don't resell CDNs or anything like that. We advise on performance alone. But your contracts with your different vendors, that sometimes there are those pricing disparities, so that's a good use case to keep in mind. We've seen it save customers tens of thousands on monthly bills. This is looking in the U.S., Comcast in the U.S. So you can see it's sort of it's very dependent on what geo you're actually looking at. This is that kind of eyesore of a chart that I mentioned. But we are basically showing, this is our portal UI. We just released this feature, it's in beta. But this is showing what would have really been tough to kind of show on that other graph. This is 3 different CDNs being load balanced on a very major global website. I've redacted the CDN names here. They're application delivery networks, dynamic HTML. So basically proxying calls around the globe back to believe it or not, a single origin in New Jersey. a very robust single origin. But what you're seeing here is we're overlaying the same time period. We're looking at the actual decision making of our OpenMix load balancing platform and how that's reacting to the actual telemetry data that it saw. So the colors are consistent between the actual CDNs. This is the performance of this called the brown CDN. And here would be, where you see brown up here, that's actually occasions in which the brown CDN was selected for because it had the best performance. So you can see that there's little bits down here where they actually have the lowest millisecond latency. Not a lot, but enough so that our OpenMix platform actually sees that and says, okay, give it over to them. For the most part, it looks like the green CDN really kind of hugs the bottom of the curve. And the idea is that up here, they're clearly taking the cake as far as the lion's share of the decisions that are being handed out. But it changes. We're looking over a day. And we're looking, oh, actually, this is a specific region in the United States, Southwest region, on Comcast. So, but over the course of that day in that specific geo, you're seeing it does change. And that's kind of the idea, is that things are not consistent. The outages and the events that we see, whether they're latency spikes, throughput drops, availability or reachability gaps, they happen all the time. We call them micro outages. We're in a pretty unique place to sort of see these types of things occurring. So we like to think that we're starting the conversation about that. Helps our value proposition, so of course that's kind of one of our drivers, but it is real. I mean, this is real data. This is looking southeast on Comcast. This is in Brazil on Global Village Telecom. This is northeast, so that was southeast Brazil. This is northeast Brazil. Not looking for you to get anything out of this other than it's a different story in different geos. And what we're actually getting from our data and what we're doing our decision making on and our data aggregation is the ASN and lowest level geo. So depending on where you are in the world, here in the United States we get down to state level geo, depending on what the geopolitical demarcations are. In China we have states, like Beijing is a state, I always thought it was a city. But other areas might get down to region. But that lowest level granularity of geography combined with the actual ASN that the user is on, that's our lowest level network map that we're collecting the data at and actually optimizing for when we're making decisions. So to us, we think that's as really kind of effectively as granular as you can sort of get. Any more than that, you're on individual nodes within the networks. So outages, so we were just looking at performance. And those graphs I was just showing you were, this is latency-based load balancing. And outages, this is the mother of all eyesores. So I'll give you a second to read that. Okay. But what we're looking at here is we took a day, and this is really just kind of to sort of illustrate the messiness and the noisiness of the internet. We took a day, we looked at the top 50 ISPs on a global basis, and we looked at the availability to all platforms, all of those, the Akamai's, Fastly's, Azure, AWS platforms that we measure with the community. To kind of get an aggregate measurement of what was the actual reachability for users on Orange in France, for example, to those, the kind of the highways of the internet, so to speak. And you can see red is clearly bad, yellow is not so bad, green is good. Over the course of the day, I mean, these ISPs have problems. I could pull up the actual color coding, just to give you a sense, but red was along the lines of 50%, which is insane. I've heard many people say that Orange is one of the most problematic ISPs. the one that gives them the most grief. So that's why you see that largely a very deep hue of red. Some other ones here that are not so good. And then this is actually looking at latency, which is even worse. I think red is, I don't have that slide, but I think red is above 150 milliseconds of latency, or 100, excuse me. So, you know, impacting your workflows for sure. But if we drill down, just to get a sense of kind of what an incident looks like for a platform, a CDN. So this was a particular CDN, one of the major ones, and it had a problem in Europe and a little bit of Africa. So this is just kind of drilling down. This is where we sort of saw the most impact was in France, a little bit in Spain, and then drilling down into the actual ISPs, you can see sort of the pattern of time over, well, it looks like a half hour. Over this course of time, you can see these are availability heat maps. You can see sort of you get a visual characteristic for the outage that occurred. And again, this is one CDN. So if you had another CDN that didn't have this problem, we would route to that, and your users wouldn't be affected by it. But if you had one CDN and it had this problem, you've got, you know, a good, I don't know, it's 7 minutes of total, 7 or 8 minutes of total outage on many of these ISPs. And if you're an e-commerce platform, that matters a great deal. And Free France Free SaaS, another common offender, I believe, could not get their act together for a very long time. So, you know, we're able to look at this and kind of theorize what happened. In this case, I think this was sort of a large POP-based CDN. I think it just went down in this area. So sort of as simple as that, but oftentimes some of them can be a little bit more mysterious, and you'll sort of have to put on your thinking cap about what actually happened there. Dig into some BGP data. It's pretty useful. The second one I just wanted to look at, I'll go kind of quick because I think we're a little short on time. But North America and South America primarily, looking on the state level, you can see that there was a pretty broad connectivity issue, as it says. This is more like a cut, right? Because we're actually looking at all CDNs, or many CDNs, probably like 5 to 10. So it's not a single vendor that had the problem. It looks like this thing was kind of flapping up and down, and maybe an internet exchange point had an issue, or a cable had a problem. And this is sort of drilling down on that outage into specific ISPs. And you can see, you know, some have problems, some don't. But in aggregate, this is taken from a very large social media site. This is looking at that concept of micro outages, like we're mentioning, those things that happen to specific CDNs that don't affect all CDNs. But the idea is, you know, having multiple paths to sort of choose from. This is an existing customer that runs their site over OpenMix load balancing. So we save them from these problems. But this is looking at the actual micro outages. Some are not that micro, actually. You can see across the bottom here, we're basically bucketing in terms of the duration of the actual outage. Looking on a global scale over 2 days. But again, it's a very, very large site, so they have a huge user base. But you can see kind of diminishing frequency with the longer that these outages get. I mean, if you get 2 to 4 hours or 4 hours plus, especially if that's happening in the United States, that's the sort of thing that makes headlines. But these up here, right, like the 1 minute, 5 minute, maybe even the 6 to 10 minute, maybe you'll see a tweet about something like that, but they're not real headline grabbers, but they happen in a massive frequency. This is 2 days. We had 107,000 1-minute outages, so that's a point at which a CDN on an ISP had a problem and was unreachable for the end users that were trying to get content across that CDN. this just amounts to quite a bit of user activity. And back to that slide that we looked at, Amazon, if they add 100 milliseconds, they lose a percent of sales. What we're talking about here is full duration outages, so not accessible. So you want to avoid that, of course. Site reliability engineers focus on this type of thing, and it does add up. This was correlated pretty precisely on the actual server logs for this customer. So I was surprised that it actually matched up the way it did. But yeah, I mean, huge amount of sort of in aggregate these small outages, these micro outages, will cause problems for your user base. We list some of the big offenders here. We can kind of slice and dice this data in a bunch of different ways, but that's pretty much it. Do you guys have questions? Anyone? Yeah.
Maybe a simple question that is elementary, but I'm not sure. And that is, so if someone is using OpenMix for their website, how is it directing, so the next person downloads, goes to your website and downloads content that is accessing CDN? Where is that going?
Where's the switch happening?
Yeah.
Yeah. I totally forgot to say that. It's critical to the solution. Thank you for bringing that up. So there's two ways to actually implement the solution. The one we've been doing since 2010, 2011 is at the DNS resolution layer. So if somebody has a primary property video.tumblr.com, I don't think that's real, but if they had that on Dyn and they CNAME that over to a specific OpenMix load balancing hostname, as the request is being resolved over DNS, we essentially point one way or the other and issue out a record or a CNAME to basically follow on for the content resolution. The second way that we've rolled out about eight months ago is just via a very, very simple web services call. So it's the sort of thing that can be integrated on the client or CMS, but basically just making a web services call to to a point that's specific to your configuration, basically with all your load balancing logic sort of programmed into it. And the response to that is a very small JavaScript or JSON package that says you should go to Akamai. If that's not available, go to Limelight. We like stack rank the options, and we can provide some other information too.
So then, so there's different. So one option is the page content doesn't change, but it goes to your kind of resolver that decides where to take it. And the other one is where the page content does change, that's been downloaded to the browser. Is that right?
The page content changes insofar as if you were to look on the console, you'd see these calls. If you integrated the web services call on the client, you'd see some network calls to our service.
Oh, I see.
But no, the actual content doesn't change.
Oh, I see.
And really, in kind of for the most part, I mean, really entirely, we don't affect anything within the HTTP session of the traffic. So the DNS-based solution is super easy. You just slot it in your DNS chain, which is really easy to do, and it can effectively do your load balancing across all your different platforms. So that's really easy to do. Clearly, making changes for the web services integration on clients, you need to be putting a little bit of work into your different clients on your different platforms.
All right.
Yeah. But yeah, I mean the idea, the benefits that we're able to provide and show for web performance are huge. Large software downloads, huge. Video, huge. So we're pretty excited, just because I mean all those workflows really are very affected by those basic network performance characteristics, latency.
Do you ever worry about like kind of flapping, or there's Like,
Yeah.
how do you kind of...
Totally. We do, yeah. We've got some secret sauce that we build into our scoring algorithms. So we don't pass raw data to the OpenMix decision-making engines that do the load balancing. We pass like thoughtfully condensed scores that take into account things like flapping. We're really conservative when it comes to availability issues, for example, and you can customize sort of all of that within your own load balancing configurations. Like if you do have a concern about flapping, you can basically make the application sort of stateful and say I'm only going to actually change my answer if the performance changes by X amount. Over the course
Over
of
a certain time.
and that has very nice performance gains.
So that was going to lend into my question.
Sure.
It's totally user defined what the thresholds are for, say you want to change load balancing based on latency.
Yeah. Yeah, if we had time, I'd love to show you guys the portal. But it's the OpenMix load balancing applications. We've got some kind of quick and easy ones where you can fire up, and like some of our biggest clients use them. It's amazing. That are just like, oh, I want to do latency-based load balancing. Maybe you want to handicap one CDN because it's more expensive than the other. Call those the quick start style applications. And then we have kind of the more intermediate or advanced JavaScript framework that you can program to your heart's content.
How do you define latency? Is it connection? Is it time to first byte? Is it time to last byte?
It's response start. We look at the resource timing API.
Okay.
For those probe objects that we go out and fetch,
Yeah.
we essentially subtract the response. We take the response start time and subtract from that the request start time. So that's our request, and then the response is that single packet is at our door to be processed. And the tag also does a lot for page load timing, and we've got some other kind of add-on type services that, since you've got that tag deployed, we can do what Google Analytics or SOSTA does, and it's totally non-sampled. Like our data platform is really, really robust and just can handle very scalably a lot of data. So we don't, we do what the advanced version of Google Analytics does in terms of page load timing performance. So that's utilizing the nav timing API. And it's just, we did it because the tag's already there. It's already on these pages. So let's just give you a little bit, another data set to work with, another tool.
So if I deploy your tag on my website for free, I get access to my data for free, or?
You get access to your data for free. Basically, the performance data for the global community benchmarks like Akamai, Fastly, Limelight, and all the clouds and stuff, from the perspective of your users. You also get to see the community data with all the sort of anonymized and bubbled up data, because your user data is anonymized and bubbled up into the community. So that's sort of how we build up the kind of the crowdsourced data set.
So we're monopolizing.
No, go for it.
But, so when you talk about, I think early on in your slides you had talked about giving kind of a view of here's what performance would have been like if you were on this cloud or on this CDN.
Yeah.
Is that like all of them, or is that just options that you have within the CDNs that you're currently using within your stack?
So that, what I just described here could give you that. So if you deploy the tag, the free tag,
Yep.
by default, your users are just going to go out and take measurements of all of the popular platforms out there. So Fastly is one of them. So his tag by default would measure Fastly from the perspective of his end users, and Akamai and Limelight and all the other ones. So in that sense, you can actually filter down to your own user data and see a stack rank. Yeah. It's a lot of data. Anybody that's just interested in sort of big data, the visualizations are cool in the portal too. If that's your thing, check it out. You might like it.
Do you guys do like map related like D3 visualization at all?
D3.
Yeah. Okay. So like heat map, layering map, stuff like that. Or it's mostly like sharp and stuff?
I know we use D3.
Okay. Now I'm more
Is that a
concerned about
good
like geolocation based E3 stuff. So
Yeah. No, however, we're one of our. We just got our B round of funding recently, so we've got a bunch of different. Thank you. A bunch of different hires. Yeah, right. A bunch of different hires in the space of data science and data visualization. So I'm really excited to see what we can do with it because I think we can do quite a bit more.
sweet.
How do you geolocate the eyeballs?
We have a couple different sort of services that we bring together, like Plova and a couple others, and we sort of overlay our own corrections where we see them. So. All right. Well, hey, thanks everybody for listening. Nice meeting you.